Hi everyone, welcome to the demo of project for SER502. In this particular project, we have worked on designing a script language and its compiler. So before moving with everything, we just want to introduce the team members. I myself am Anand Gupta.
So I'm Atul.
Hi, I am Harish.
Okay, so moving on to the table of contents. So in this particular demo, we are going to be covering the introduction to the language, that is like the basic features of the language, idea behind the language, these things. Then comes the how can one install on their system and run the programs which are written in a script language. Moreover, we will cover the constructs which are supported by the language, as well as the grammar rules for which the compiler is written. Then moving onwards to other sections, like we will discuss the lexer, parser, and evaluator for our compiler.
We have tried to basically incorporate the C style of programming constructs, and the most of the syntax which we have incorporated is basically inspired from Bash. The language of development we've used over here is Prolog. And finally, the language which we have developed is more kind of interpreter style in nature. To also quickly give some details on what exactly interpreter is. So in an interpreter style language, we basically focus on two main components, a parser and an evaluator. Obviously, there's also a lexer in between. The parser basically reads the input program, breaks it down into smaller tokens with the help of the lexer, and which is finally analyzed and interpreted by the evaluator. Lastly, the language which you have developed is kind of machine agnostic in nature, so it does not depend on a specific machine to run on. Now, talking about on the flow of the programming language over here. So, as you can see over here, the first stage is used basically. In the very first stage, we have a input program which should have an extension of .shc. Now, this file is basically passed onto the lexer, which takes into the raw input as a source code, further breaks it down into a sequence of smaller tokens. These tokens are ideally the basic building blocks for the language, and they can basically represent keywords, operators, literals, or identifiers. Once the lexer has produced a sequence of tokens, those tokens are passed onto the parser, which is then again giving out a parse tree as an output. This parse tree represents the structure of the program according to the rules which are defined onto the language grammar. Lastly, the parser generates these rules, which needs to be validated at the end, for which we have the evaluator. So once the parse tree is generated, we make use of the evaluator. It traverses the parse tree which was earlier generated, executes the instructions that it represents, and finally gives back to us the computation, which we call as the output at the end.
Based on the constraints which are provided for the project, we have incorporated numeric data types. That is simple integer. We are not covering floats. Then there are booleans which can take true or false value. And then there's the string which can be composed of various characters. It can either be enclosed in double quotes or single quotes. We have defined several keywords which are there in our language. This cannot be used as an identifier. So you can see main, end main, var, if, else, and if, for, and for, while, and so on. So as you can see, most of the constructs, they have their closing as end. It's like, for example, if there is a main, then there is corresponding end main. If there is a if, there is corresponding end if, and so on. The operators which we support in a language are categorized into 4 categories. Logical operators, which are and, or, and not. Arithmetic operators, which are related to the arithmetic operation, which we can do, plus, minus, multiply, divide. There are replacement operators and other operators like assignment operator and ternary operator. So this is about the operators. Moving on to other constructs for conditional and looping. So we have if support, if then, there is support for if then else. there is support for, in the iteration, we have support for for loops, we have support for in loops, and we have support for while loops. So you can see the syntax also mentioned over here. So this is how you write conditional and iteration constructs in struct language, in script language. Moving on to the language grammar, I will hand over to Irish to discuss the language grammar.
Yeah, so the language grammar starts with the program block. So it basically specifies the overall structure of the program. Like, so it defines, it starts with a keyword main followed by a block statement enclosed in curly braces, and it ends with the keyword end main. Then block statement we have defined, it's a sequence of statements separated by semicolons, and it can also be empty, like the epsilon specifies that. Then there is the statement definition. So a statement can either be one of the 5 types, that is either a variable declaration, an assignment, a conditional statement, a loop, or a print statement. Then declaration, it's like defined with a var identifier. After that, you can see assignment, which is like can either be a variable assignment where an identifier is assigned, an expression, or a string, or it can be an initialization where an identifier is assigned a value when it is declared. Then on the right side, you can see first the 3 basic data types defined, like the number is either made up of digit or digit followed by number. And Boolean, like it can contain 2 values, true or false. Then string is defined by either a single character or a series of characters.
Okay, so I quickly jump onto the grammar part wherein the expressions are defined. So over here, in this particular programming language, we have basically incorporated 3 different types of expression values. First one is the Boolean one, second one is the arithmetic, and third one is the ternary expression. Now for each of these expression, we'll one by one kind of define how exactly the syntax and how exactly the code should be written so that it is being passed as per the grammar rules. So we basically start with the first one, in which we have the Boolean expression, which kind of represents the expressions that can be evaluated as any of the Boolean values. So this is basically true or false case. Now for this, we define various different kinds of operators which can be used. So we have the double AND operator, we have the pipe operator, which translates to an OR functionality. We have the comparison operator over there, not equal to operator. So all these things are defined onto the grammar. Next, we move on to the comparison part, wherein we can compare 2 different arithmetic operations using any of the operators that we have. So we define a construct for that, wherein we have the arithmetic expression, we have some relational operator in between. Then again, we have an arithmetic operation. So this is one of the formats which can be taken into consideration, or else it can also be taken into the another way in which we have a negation up front. Then we have a Boolean value, which can be followed by a Boolean expression. So this is another form of comparison which can be done. Lastly, there can be a single constructs for Boolean and identifier as well. Next to it, we have the relational values coming up with us. Relational values are all the comparisons which can be done for the arithmetic expression. Lastly, we define for the arithmetic expressions which can be evaluated again as numeric values. It can be made up of arithmetic operators such as plus, minus, multiply, or division. It can contain some parentheses in between, which is again defined into the grammar rules.
Okay. So moving on to the next section, I will discuss about the grammar related to conditional and iteration structures. So we have if then statement, and we have if then else statement. So that is covered by the conditional. We have ternary expression, which is Boolean expression followed by question mark, and then 2 expressions separated by colon. We have support for while, and for in, as you can see over here. It has a similar syntax to that of C or C-like languages. Then finally, we have a print construct for printing the identifiers. you could simply write print space and identifier name. So this is about the language grammar. Moving on to the components of our compiler. First one is our lexical analyzer. So this is written in Prolog. We have used the initial tokenizer present on Rosetta Code website, and we have modified it to spit out tokens based on our grammar. So these tokens are in form of token, and then the tuple is like a type of the token and the value associated with it. You can see the source code of lexical analyzer in lexer.pl file. Parser, these would be the tokens which would be generated. It would be only in this domain only. So it can have keywords, operators, symbols, and string integers and identifiers, as you see over here. Moving on to the parser module. So this one is also written in Prolog. The file associated is parser.pl. So it takes the input from the lexer and generates a parse tree. We are using difference. We are using difference list to do the computation over this. All our grammar, all our code in parser file is in DCG notation as supported by Prolog. Next comes the evaluator component. So this one is also written in Prolog, and the associated file is evaluator.pl in the source folder. So this takes the abstract parse tree generated by the parser and gives you the output. So the output is in form of like if you have written print statements, it's gonna generate the output. If you don't have any print statements, it's just gonna terminate. So before moving with our sample programs, I will first give you a brief overview of how all these modules are integrated. So first one is our application file, which is the starting point of our application. So we call this execute method. So execute method loads the file, whichever is provided as an argument. It reads the file, and then tokenize method. So a predicate, this method, this predicate is defined in the lexer file. So it takes in the character array, character list, and gives out the tokens. So as you can see over here in the lexer, so this is our lexer file. So we have used the source code present at Rosetta code, and most of the things are same, but we have modified the grammar rules for it. So for example, what are the operators that are supported in our grammar? What are the symbols which are supported in our grammar? What are keywords supported in our grammar? And then there are tokens for identifier, integers, and strings. So these are the things. Spaces are trimmed out by the tokenizer, so we need not to worry about those things. Anything else, if anything else is passed, the tokenizer would give you the error that there is an invalid token at line number this and column number this. So this one is Elixir. Then moving to the pre-process step. So as you can see, the tokenizer, it gives you also the row and column value. So we have to pre-process the tokens so that our parser could generate a parse tree based on that. So we have already discussed the parse predicates, which is defined in parser.pl. So it takes a list of tokens and it gives out the parse tree. This parse tree is passed on to evaluate method, which is our evaluator. And finally, we halt the operation since evaluator would do all the computation. So the evaluator is defined for all our constructs which we have defined earlier. So these are all the things which the evaluator would need to pass the parse tree to evaluate the parse tree. So it has support for all the blocks, statements, expressions, operators, keywords, and looping helpers. So these are there in our language. Finally, to manage the symbol table, we have lookup, update, and remove method. So this is the flow of our compiler, how it treats the source code and prints out the result. Next, we will move on to the sample programs which we have written in script language. So first one, we are going to discuss in detail about the factorial. It starts with the main and ends with the end main, and in between we have all the block. So it has a var to define the variables, like n is equal to 5 factorial. Then it has a while construct ending with end while. So you can also see every statement is ended by the semicolon so that we have consistency across all the statements. Finally, we print the statements like print this and print the value of the factorial. So this is our source code. If we analyze the tokens which are generated by lexical analysis, so you can see it has like token and the tuple of what type of token it is and the value of that token. So this is the list generated by a lexical analyzer. This is then passed on to our parser, which generates a parse tree. So this is the parse tree which is generated for a factorial program. So as you can interpret from the parse tree, it says, okay, first comes the declaration saying n is equal to 5. Then there is a statement again that says factorial. This is again a declaration factorial is equal to 1. Then comes other statement. So this one is a whole while loop. So there is this condition which says n is greater than 0, do these steps. So these steps can be said as like first say, okay, factorial is equal to multiply factorial into n. And then there comes a statement, you have to reduce the value of n by 1. So n subtract n by 1. And finally, we have the print statements. So once we run the program, since we had 2 print statements, so this was like the factorial of 5 is this, and finally the value of that